To everyone working at that secret bunker in Nebraska, any interference with their system meant only one thing. The Soviets were trying to blind them. And if they were jamming the radar, it was because the missiles were already in the air. The Ballistic Missile Early Warning System, or BMEWS, was built to do one thing: spot incoming enemy missiles in the minutes after launch, before they reached American soil. 3 radar stations spread across the top of the world, sweeping the shortest path those missiles would travel. Together, they had just enough time to verify an attack, wake the president, and authorize a response. The network had been running since 1960, built station by station, hardened against blast, designed to keep transmitting even as the world ended around it. Because of this, at any given moment, 1/3 of the entire American bomber force was fueled, armed, and ready to go at any time. Strategic Air Command ran constant drills to keep it that way. Crews scrambling to their aircraft, engines starting, planes taxiing to the runway, and in the most extreme exercises, actually taking off. The men knew the sequence so well, they could execute it in minutes. To top this off, more aircraft were always flying continuous patrol routes across the Arctic. On May 23rd, inside the SAC headquarters bunker outside Omaha, Nebraska, hardened against blast and connected by dedicated lines to every corner of the nuclear arsenal, Al Buckles sat at his desk. He was the man on duty as emergency action controller, working his daily shift. Waiting, as he did every day, for the call that would tell him that the country was under attack. A message that had never come. While the men of SAC watched the skies, a small group of Air Force observers was watching something else entirely. In May 1967, the most dangerous thing in the sky was the sun. At Sacramento Peak Observatory, in the mountains of southern New Mexico, Air Force observers Howard Damastis and Ron Stover ran a flare patrol. Every day, they watched the sun's surface through specialized telescopes, tracking it for signs of instability. On May 18th, a sunspot region, designated McMath Region 8818, rotated into view. Sunspot regions are temporary dark patches where intense magnetic fields suppress the churning plasma beneath them. Damastis and Stover had seen hundreds of them, which is why they recognized immediately that this one was different. The magnetic field lines running through it were tangled in ways that set it apart from anything they'd seen in years. Vast, complex, unstable, in a way that made both men uneasy. 3 days later, the active formation released a white light flare, one of the rarest and most violent events the sun produces, so energetic that it becomes visible against the face of the sun itself, burning bright enough to be seen with the naked eye against the most luminous object in the sky. Shocked, Damastis and Stover watched it bloom across the surface and stayed at their telescopes. Through it all, their notes were logged and reported up the chain of command, the information traveling hundreds of miles to the northeast, where, carved into the granite of the Rocky Mountains and sealed behind blast doors, was the NORAD headquarters. And inside it, in a small operations room that almost nobody knew existed, was a unit called Detachment 7. Placed inside the same building as the people who controlled America's nuclear response, their job was not just to watch the sun, but to tell the most powerful military command in the world what it was about to do. It had started with just one forecaster and one observer in the autumn of 1965, and had grown into a global network, pulling data around the clock from observatories across the United States, from Greece, from the Philippines, feeding it all into the heart of Cheyenne Mountain. Its commander was Colonel C.K. Anderson, who had written the forecasting manual himself. On the morning of May 23rd, the duty forecaster was Captain Lee Snyder. Alongside him was Major Donald Sherry. Both had been watching McMath Region 8818 build for days, tracking the same white light flare Damastis and Stover had seen 3 days earlier, watching the same data come in from observatories across the country, all of it pointing in the same direction. That morning, Detachment 7 had already issued warnings to the NORAD command post. Another eruption was coming. The sun was about to do something it hadn't done in years, and America was about to find out the hard way. Just past 6:40 p.m., a flare erupted from the surface of McMath Region 8818, tearing through the sun's atmosphere in a wave of ultraviolet light and X-rays, moving at the speed of light itself, crossing 93 million miles in 8 minutes, and arriving at Earth's upper atmosphere before anyone on the ground had time to process what had just happened. Only moments later, a second and much larger wave of energy tore across the face of the sun, so fast and so vast that at Sacramento Peak, Damascus and Stover could see it moving. But it was the third and final flare, a white-hot eruption so huge and so sudden that it sent a pulse of radio energy racing outward in every direction at once. At 606 megahertz and 373,000 solar flux units, it was the largest solar radio burst ever recorded in the 20th century. Everything on the sunlit side of the Earth that depended on radio waves was being swallowed by the noise. Across the continental United States and Canada, radio communications began failing. The Panama Canal Zone went silent. A geostationary satellite lost its signal. At Thule Air Base in Greenland, the BMU's antenna faces were pointed almost directly at the setting sun, operating at 440 megahertz, completely exposed to everything McMath Region 8818 was producing. From one moment to another, the system could no longer distinguish an incoming Soviet missile from the background noise. It was indistinguishable from jamming. Suddenly, all 3 ballistic missile early warning system stations went dark at the exact same time. The only reasonable response now was to trigger the nuclear launch sequence and let the decision come from elsewhere. Back at the SAC headquarters bunker in Omaha, Nebraska, Al Buckle's phone rang. All 3 stations were down, simultaneously, with no explanation. Nothing like this had ever happened in the entire history of the network. A single station going offline had protocols. 2 stations had escalation procedures. This unprecedented event could only have one meaning, written into the doctrine of every officer who had ever worked within the system. The United States was under attack. Buckles got on the line with NORAD in Colorado Springs and with the National Military Command Center at the Pentagon. Within minutes, the Emergency Actions Team, the men whose entire professional lives had been organized around this moment, trained for it, wargamed through it hundreds of times, assembled. Around the table, nobody was panicking. They were doing exactly what they'd been trained to do. A group of additional nuclear-armed bombers was moved to ready-to-launch status. Aircraft already airborne continued flying their patrol routes, armed, ready, and waiting for any kind of update. In Washington, the decision chain was rapidly moving upward and toward President Lyndon Johnson himself. What nobody in any of those rooms could see yet was what, for the past hour, the second solar burst had been quietly working through. The high-frequency radio bands that Strategic Air Command used to communicate with its aircraft, steadily destroying the only frequencies that could reach the bombers already in the air, all without triggering a single alarm. So while the Emergency Actions Team assembled in Omaha, and while NORAD ran its protocol, the sun was silently cutting the one line of communication that could still stop a full-blown nuclear war. And now, somewhere over the Arctic, nuclear-armed bombers were already in the air. And even if someone managed to get a signal through, SAC crews were trained to complete their mission, unless they received a clear recall order. Inside one room, the entire crisis was about to turn. Deep inside Cheyenne Mountain, the phone rang at the Detachment 7 office. In the chaos of the past few minutes, with bombers moving to launch status, and the emergency actions team assembling in Omaha. Someone had finally thought to ask the solar forecasters if anything significant was happening with the sun. Somewhere in the chaos of those first frantic minutes, someone in the NORAD command post thought to pick up the phone and call Detachment 7. Captain Lee Snyder picked up. He already knew. He'd been watching McMath Region 8818 for days, tracking data coming in from Sacramento Peak, from Sagamore Hill, from observatories in Greece and the Philippines, all of it feeding into Detachment 7's operations room in real time. He'd filed warnings that morning. He'd watched the flares erupt in succession. When the question came, he did not hesitate. Quote, "Yes, half the sun has blown away." Then, as he would recall decades later, he gave the details in a calmer, more quantitative way. The timing of the flares, the operating frequency of the BMU's radar, the angle of the antenna faces at Thule, pointed almost directly at the setting sun at the exact moment of the eruption. All of it coming through on phone lines and teletype, the only communication technology Detachment 7 had, delivered by a captain, a major, and a colonel, in a room that most of the people making decisions that day had no idea existed. Besides Snyder were Major Donald Sherry and Colonel Anderson, the man who had built Detachment 7 from nothing, written the forecasting manual himself, and spent years trying to convince the highest NORAD officers that the sun belonged in the same conversation as Soviet missiles and should not be ignored. At last, they had that conversation. But knowing the truth was one thing. Getting it to the right people in time was another. Snyder's assessment was moving upward through the chain, from Detachment 7 to the NORAD command post, from NORAD to SAC, from SAC toward the Pentagon. The message, it was the sun. Stand down. At the same time, the launch sequence was still running. More bombers on alert. The President closer to the phone. Both sides have spent 20 years designing a system so automatic, so guaranteed, that once it started moving, it was almost impossible to stop. The message moving up and the launch sequence moving down were now racing each other, and nobody outside a handful of rooms knew both were happening at once. The records have never fully explained what happened next. The calls that were made, the voices on the other end. The moment someone with enough authority looked at Snyder's data alongside everything else and made a decision. None of it was written down in any document that's since been made public. The Air Force's internal records describe those minutes in language so careful, it says almost nothing at all. Diane Knipp, the researcher who spent years reconstructing the sequence from declassified files, said she still could not say with certainty who made the final call, or whether the President was even told. What the paper trail does show, pieced together 40 years later, is that somewhere in those minutes, aircraft engines began to cool. Bombers that had been moved to ready-to-launch status returned to normal alert stance. The launch sequence stopped. The crisis, whatever it had been, seemed to be over. But 40 hours later, the sun hit the Earth again. The bombers had stood down. The sun had not. The flares on May 23rd had done more than produce radio noise. They'd launched a coronal mass ejection into space, a cloud of magnetic plasma, moving at over 1 million miles per hour, carrying within it the energy of thousands of nuclear weapons. It had taken 40 hours to cross 93 million miles. On May 25th, it arrived. One of the most powerful geomagnetic storms in modern scientific record began that day and lasted nearly a week. Auroras blazed across the night sky, as far south as New Mexico and Alabama, visible over Washington, D.C., hanging overhead in colors that people who saw them said they had never seen in the sky before. Radio communications were disrupted across the entire northern hemisphere for days. The magnetic field of the Earth shuddered under the impact and took nearly a week to fully recover. McMath Region 8818 kept producing flares for another week. Within months of the incident, the Air Force dramatically expanded its space weather operation. New solar observatories were funded and built. More forecasters were trained. Formal partnerships were established with what would become the National Oceanic and Atmospheric Administration. The unit that had existed for barely a year, with a forecasting manual 13 months old, grew into the organization now known as the Air Force Weather Agency's Space Environment Team, the direct institutional ancestor of every space weather monitoring system the United States operates today. The Soviets had been watching too. A Russian colleague of NIP's told her that after 1967, the Soviet Union sharply increased its own funding for solar observatories. Both sides had looked at what had almost happened and drawn the same quiet conclusion. The sun was a variable they had not accounted for. They needed to account for it. And in an almost perfect coincidence, the storm that nearly started a nuclear war ended up being the most scientifically valuable solar event ever recorded. Only one day before the crisis, on May 22nd, the Air Force launched a classified satellite called the Low G Accelerometer Calibration System, or LOGACS, designed to measure atmospheric drag, with nothing to do with solar weather. Since the secretive device happened to be in orbit during the storm, it accidentally captured the most detailed measurements of an extreme geomagnetic event anyone had ever seen, data that scientists would spend decades studying. However, the May 23, 1967 near-miss story was classified almost immediately. For nearly 50 years, almost no one knew this had happened. The Air Force's internal records describe May 23rd in language so carefully chosen that when Diane Nip finally dug through those files nearly 4 decades later, she noted they delicately sidestepped exactly how close it had gotten. The declassified documents acknowledged the solar event. They acknowledged the disruption to the beam use. What they did not acknowledge, in any language direct enough to be quoted, was the sequence of decisions that had unfolded inside Cheyenne Mountain while 2 streams of information were moving in opposite directions through the command structure of the American nuclear arsenal. Nip spent years reconstructing that sequence, interviewing surviving participants, cross-referencing signals intelligence logs with solar observation records, and tracing the chain of calls from Sacramento Peak to Sagamore Hill to Detachment 7 to the NORAD command post to the Pentagon. Her paper, when it was finally published in 2016, was the first time the full story had been told outside classified channels. It had taken 49 years. However, the men at the center of it received no public recognition at the time, and little since. Anderson, Sherry, and Snyder, the 3 men whose unit had existed for barely a year, whose forecasting manual was 13 months old, who'd convinced a nuclear command center not to launch on the basis of data coming in over phone lines and teletype. Their names appear in Anderson's online memorial tributes, published after his death in late 2015, credited with proving the information that calmed nerves and allowed aircraft engines to cool. That is the extent of the public record. Buckles, asked about it years later, described the experience with the economy of a man who had spent a career inside systems where precision was everything. Quote, "Every minute was a training minute. There was no room for misinterpretation. A mistake could cause a whole lot of unwanted things to happen."